It's going to be lecture 4. Yeah. Is my slide visible to you? Anyone? Please confirm.
Yes, sir.
Very good. So transmission medium, right? We need to understand what is transmission medium. So you see, ultimately, the signals, whether it is the digital signal or whether it is the analog signal. Has the recording been started?
Yes, sir. New recording has been started.
Very good. So transmission medium, we need to really have little bit of knowledge. We don't need to become an expert, because these are whatever we are covering right now are topics which are more of interest to students who study, data communication in electronics departments. For them, it is more of an interest. But you see, computer networks without understanding these fundamentals also is not possible. So that is the reason, small concepts which are important for you to understand, the more important concepts for computer science students, those I am trying to cover in these first few lectures. Okay, so let us have a quick understanding of transmission medium. So these transmission medium basically are the media through which these signals, whether these are analog signals or the digital signals, these are going to pass. So analog signals like your sine wave kind of analog signals, which are continuous over a period of time, or these digital signals which have discrete plus V minus V kind of voltage levels, those are going to pass. So you need some medium. Now, what are these different types of media? So we need to really understand. So before we get into these different types of media, let us try to understand what we are getting into. We are talking about the sender node and the receiver node. The sender computer, receiver computer. So this physical layer in each of these computers, we still do not know what is the concept of layering. So for now, just you assume that there is some component in each of the sender and the receiver which is responsible for transmitting the signals through certain media. So this medium can be in the form of a cable, or it can be the air medium. If it is in the form of a cable, it is called the wired network. If it is in the form of air, then it is wireless medium. Now, so wireless, I think everybody is pretty comfortable with in terms of using wireless communication media, because your mobile phone basically communicates through wireless. Your, the TV remote, the remote with the remote device with your television, where you are able to turn on your television by pressing the remote button, or where you are able to change the different channels of your television by pressing different buttons of the remote. So that's basically the communication that takes place between the remote and the television is again wireless, right? So the communication happens over the transmission medium air as the transmission medium. Whereas if you are talking about most of the offices, right, or in your computer lab, so where the computers are basically connected by some cable, right? So this is something that you have all seen, right? The computers are connected by some cable, and the data transmission basically takes place through certain cable, right? So that's the wired medium, right? So a transmission medium can be broadly defined as anything that can carry information from a source to a destination. Okay, so from a source, from a sender to a destination, receiver. So this is the transmission medium which basically carries all the signal elements. So you can have transmission media which could be air, like free space, metallic cable, fiber optic cable, and so on. So everybody understands now what is the transmission medium? Now let us try to understand a little deeper. The transmission medium can be taxonomically classified into broadly two types. One is called the guided medium, whereas the other type is called the unguided medium. Guided means, like, all the signals are going to be guided. These are going to be confined within the boundaries of the physical medium, the wire, the cable. The signals are going to be confined within that. Whereas in unguided, it's a free space, right? The signals basically propagate in different directions. Now, this guided medium can be further classified into broadly three types of media. One is the twisted pair cable, the second is called the coaxial cable, and the third is called the fiber optic cable. These are the three main types of cables that are used. Of course, with the advancement of communication technologies, there are many different types of material, different types of media which are also being experimented with. But broadly, we can think of as twisted pair, which is very traditional, coaxial, which is also a little traditional, but again, it is slightly more improved type. And then you have the more advanced one, which is the fiber optic cable, right? And unguided is basically the air, the free space. So let us have a quick understanding of these four different types of media and their different specifications with respect to the frequency range, the typical attenuation, the typical delay, and the repeater spacing. What is the repeater? I told you in a previous class. After propagating for a certain duration of time, the signal strength gets reduced after propagating for certain duration of time. So that is why you need to really have, so you need to have this thing. You need to have the device called repeater. So we will understand, the concept of repeater, router, bridge, switch, etc. We'll look into these things in more detail. We'll encounter these terms more in the latter weeks of this semester. So for now, let us have a quick comparison between these different types of media. So twisted pair, so what is twisted pair? That we will see. So twisted pair with loading and twisted pair with multi pairs. So anyway, the twisted pair, basically the frequency range is from 0 to 3.5 kilo, 0 to 3.5 kilohertz for twisted pair with loading, and twisted pair multiple pairs, basically this is 0 to 1 megahertz. Little bit improvement has been made in terms of the frequency that it can pass, right? And the typical attenuation again is the signal strength being reducing, right, with the propagation. So signal strength reduces. So it is basically 0.2 decibels per kilometer, right, for 1 kilohertz transmissions, right? So for this is for the twisted pair. For twisted pair with loading, twisted pair with multi pairs, basically the attenuation is 0.7 decibel per kilometer. Okay. Then the typical delay is 50 microsecond per kilometer, and this one is 5 microsecond per kilometer. So you see the delay is more over here, and the delay is less over here. And the repeater spacing is the same for both the categories. Now, if we compare this twisted pair with coaxial, in coaxial the frequency range is 0 to 500 megahertz. You see, from maximum 1 megahertz, now it has been increased to 500 megahertz. So 0 to 500 megahertz. Okay. In optical fiber, on the other hand, we are talking in the range of terahertz. So frequency range is in terahertz band, right? So terahertz range, right? And so attenuation basically is 7 decibel per kilometer for coaxial cable, and 0.2 to 0.5 decibel per kilometer for optical fiber. And the delay is in 4 microsecond per kilometer and 5 microsecond per kilometer. And repeater spacing is 1 to 9 kilometers in coaxial cable. So earlier it was how much? For for twisted pairs, basically it used to be something like roughly 2 kilometers, where the repeaters will have to be placed in order to boost the signals up, right? So here here it is going to be coaxial cable, it is going to be 1 to 9 kilometers. So significant improvement in performance. So in optical cable, on the other hand, it is in the order of 40 kilometers. You have to place a repeater after every 40 kilometers. So you see how much improvement you can have with respect to optical fiber. So that is where, optical fibers, wherever we are talking about high data rate communication, optical fibers are attractive. Okay. Now twisted pair cable, what is it? Let us try to have a visual look. So two conductors which basically are joined, intertwined, right? These are basically twisted, intertwined in this particular manner, okay, in twisted pair cable. Now every cable has the metallic core, which is basically through which the signal travels, okay, and there is some insulator material, the pink color one that you can see, the insulator material, which has been kept in order to reduce the effects of signal loss, right? In order to reduce the effects of signal loss. So twisted pair cable can be again classified into two types. One is called the unshielded twisted pair, UTP. This is a term that you will commonly encounter, unshielded twisted pair. The other one is called the shielded twisted pair, shielded twisted pair. So this is how this unshielded twisted pair looks like. So you have the twisted pair. In unshielded, you have only a plastic cover to enclose this twisted pair of cables. Whereas in the shielded twisted pair, in addition to this particular configuration, you also in between, you also have a metallic shield like this, which can be used to reduce the amount of interference that it is going to have from the external sources. External EMI interference, it is going to reduce. Okay, this is basically the metallic shield, which is going to help in reducing the interference. Now, although this is cheaper and is more commonly used, UTP, this one is more expensive and it is harder to handle because it is thicker than the UTP. The STP is thicker than the UTP, and also it is heavier. On the contrary, although UTP is cheaper, it suffers from external interference, EMI interference, electromagnetic interference. STP improves on the effects of external interference, whereas UTP basically suffers from this external interference, electromagnetic interference. So that's the difference between these two classes of twisted pairs, the UTP and the STP. So let us quickly have a look through these two types. So twisted pair cable, okay, can be again classified into different types, like something called category 3 untwisted pair. Sorry, unshielded twisted pair. Unshielded twisted pair, category 3. Category 5 unshielded twisted pair. 150 ohm shielded twisted pair. Okay, so these three types. So attenuation, which is basically measured in decibel per 100 meter, as you can see in the category 3, which is also commonly called as Cat 3, Cat 3 UTP, Cat 5 UTP, right? So Cat 5 is more common for us. We all are with Cat 5, right? So I'm going to show you these things later on. So you see that category 3 UTP at the frequency range, frequency of 1 megahertz, the attenuation is 2.6 decibel per 100 meter. On the other hand, for category 5, it gives a little bit of better performance with respect to attenuation. It is 2 decibel per 100 meter. So you see that attenuation is less in Cat 5. In Cat 3, the attenuation is more. So Cat 5 is better than Cat 3 in that sense. And if you are looking at STP, the attenuation is even less. It is only 1.1 decibel per 100 meter. So the same observations, if you look further for higher frequencies, you'll be able to see a similar kind of pattern. Now remember, for higher frequencies, Cat 3 UTP is not much usable. Frequencies in the range of 200 megahertz to 300 megahertz or beyond, Cat 3 is not much usable. For this, you need to use Cat 5 up to about 100 megahertz frequency. And even beyond, STP will be useful. So similar kind of observation in terms of improved performance of Cat 5 and STP over Cat 3 can also be obtained, can also be observed with respect to the crosstalk. So crosstalk, which also I talked about in a previous class, can be of two types. One is near end, the other one is the far end. So near end crosstalk basically, when you are talking about a particular circuit, so near end crosstalk talks about how much crosstalk you are going to have, how much the circuit is going to have, how much the near end of the circuit is going to have crosstalk at the, so this is measured basically with the help of near end crosstalk. Okay, so these different values, so these are basically written over here. These are shown over here. So the categories of UTP and their different specifications. So UTP category 1, 2, 3, 4, 5, 5E, 6, 7. Cat 7 also nowadays we have, right? So Cat 1 was basically the telephone lines. Cat 2, Cat 3, basically Cat 3 onwards are used in local area networks. Okay, so go through these different specifications, this particular table, and try to have a feeling of how the data rate gets improved with the improve in the category, not improvement, but with the increase in the category level. How the data rate is improved, right? So try to go through this table and try to have a feel for it. So the standard bandwidth, maximum data rate, so that comparison also I have shown over here for category 5E, which is improved over Cat 5. So 5E, Cat 6, Cat 6A, Cat 7, Cat 8, the bandwidth and the maximum data rate. So in a sense, basically, the more you go up in the category level of the UTP, you are going to have improved data rate, much improved data rate. Cat 5E is giving you 1000 Mbps, whereas Cat 8 is giving you 25 Gbps or 40 Gbps transmission capabilities. Okay. Okay, so these are the UTP connectors. There is something called RJ45, right? So RJ45 is the one that you use, quite commonly, like in your laptop also. If you are connecting your laptop to the Ethernet cable or or your LAN, mostly you are going to use this unshielded twisted pair, right? So unshielded twisted pair RJ45 connector. Basically, connector means like the point where it connects, right? The cable connects to your computer, right? So that is the connector. So tomorrow, actually, I'm going to talk more about these connectors, right? I'm going to show you a video which will give you a better feeling than these pictures about what these connectors are all about and how they all differ from one another. So this is the RJ45 male and RJ45 female. So basically, this RJ45 how they connect with port that basically is shown over here in this particular picture, right? And the corresponding attenuation values for the different gauges of these UTP connectors. These are also given in this figure. This is not much important, but what is important for you to understand and know is that these RJ45 connectors are commonly used in your computers, right? So yeah, so this is what you have seen. So the advantages of twisted pair cable I'm not going to go through, and the disadvantages also I'm not going to go through, but nonetheless these are important for you to go through, and you need to understand the advantages and disadvantages of both of these. These are pretty like simple textual stuff, which I think anybody who understands English would be able to understand them pretty well. If you are not able to, let me know in the next class. I will explain to you. So next class we are going to talk about some advanced forms of cables which are going to be covered, and I'm going to show you a video with all these different types of cables, right? Cables and the different types of connectors. So that's all. We are 5 minutes over time. Any quick questions? Okay, if not, thank you very much. We are going to meet tomorrow for the theory class, and today again in the afternoon at 2 o'clock for the lab. Thank you. See you. Bye bye.